So hello everyone, this is lecture 2 part 1 of dual nature of radiation and matter. I am Sameer Lavankar. Let's begin our discussion from the previous topic which was photoelectric effect. So let's start the discussion directly. So first of all, course outline for you. Right now we are on the third point, just the end, only the last discussion is left in the third point. Before that we started with the introduction in which we understood the dual nature of radiation. It is about different scientists, as in what they did, how was the discovery being made, etc. Then in the electron emission we understood the concept of how an electron can be emitted out from the metal surface, what is that threshold energy required, what is that workout potential, etc. In the last lecture we concluded the concept of photoelectric effect, that is if some amount of ultraviolet light is being irradiated on the metal surface, then the amount of electrons can be ejected out from the metal surface and it can move from, let us say, from one plate to other plate and can cause electric current to flow through the circuit. How was it done? Was explained using that cathode ray tube experiment. Let us conclude the photoelectric effect and let us move on today with the fourth point, that is experimental study of photoelectric effect. Okay. So let us start the discussion directly. So photoelectric effect was being understood. So in the previous lecture we understood two different experiments. One was of the Hertz observations and the second was about Helmholtz and Lenard's observations. So yes, so in the last class we were here. So let me just iterate everything again from here. So in the last lecture I explained to you about the threshold frequency, that is there is some amount of frequency after which only this emission of electrons starts taking place. That frequency at which this electron starts, the electrons are being ejected out, is called as threshold frequency. Okay, so let me start the discussion from this line only. So Helmholtz and Lenard also observed that when ultraviolet light fell on the emitter plate, so please remember this is the emitter plate, no electrons are emitted at all when the frequency of the incident light was smaller than a minimum certain minimum value. That certain minimum value was called as threshold frequency. That certain minimum value was called as threshold frequency. Okay. So this minimum frequency depends on the nature of the material of the emitter plate, quite evident because it changes. It depends on the work of potential, it depends on the material, whether it is cesium, whether it is platinum, etc. Okay. So it was found that certain metals, now please remember because in sometimes in, let us say, very short answers this may be asked that which are the things which have a higher potential and which have a lower potential. So please look very carefully. So it was found that certain metals like zinc, cadmium, magnesium, etc. responded only to ultraviolet light having short wavelength to cause electron emission from the surface. However, some alkali metals such as lithium, sodium, potassium, cesium and rubidium are sensitive even to visible light. What does it mean? That the light which is passing through need not be ultraviolet light for these elements such as lithium, sodium, potassium, etc. Even visible light can cause electron emission from the surface of the metal and the electric current can flow through the circuit. So that thing is only explained here. Next is all these photosensitive substances emit electrons when they are illuminated by light. Quite evident, as the name suggests, photosensitive. What does it mean by photosensitive? As in when the light is being emitted, photosensitive, as in depending upon the amount of light acting on the surface or illuminated by irradiated, the electrons are being ejected. So all these photosensitive, as in the substances which are sensitive to photons or photons, so light. So all these photosensitive substances emit electrons when they are illuminated by light. After the discovery of electrons, these electrons are termed as photoelectrons, quite evident. So as the name suggests, because these are being ejected due to the emission or due to the irradiation of light or photon from the surface of the metal, hence these electrons are called as photoelectrons. Okay. So this is the new thing. So please keep on remembering these all instances. One thing which you need to remember is what is threshold frequency, because a definition can be asked, and another is you should know the metals which are more sensitive and which are less sensitive. So you can just remember lithium, sodium, etc. are more sensitive and hence can be visible by, can be irradiated, the electrons can be irradiated due to a visible light also, but there are some other metals such as zinc, cadmium, magnesium, etc. which requires or which can be ejected, the electron can be ejected only when the ultraviolet light is being intact upon it, when it is being irradiated by ultraviolet light. Okay. After this, you should remember what are called as photoelectrons. So, basically they are electrons only, but because they are ejected by the concept of, or let us say the phenomena of photoelectric effect, hence these electrons are called as photoelectrons. Okay. This phenomena, so this complete phenomena, or this complete discovery, which is the complete procedure from the emission or the irradiation of ultraviolet light, or let us say visible light, depends upon the metal. So, we can say just for instance on light. So, the phenomena or the procedure of the irradiation of light on the metal surface, which leads to emission of electrons from the metal surface out from its surface, is called as photoelectric effect. How it can be used? Here it is used such that these electrons, as they eject out, they move in similar fashion, they get attracted towards the positively charged positively charged plate, and hence the electric circuit is completed, and hence the electric current flows through the circuit. Okay. Therefore, the phenomena is called as photoelectric effect. Okay. So, this was the complete discussion of photoelectric effect. Let me stop this discussion and let us move on to the next discussion now, because this photoelectric effect will come into picture again and again in this complete chapter. Okay. So, this is the complete phenomena of photoelectric effect. Okay. Let us move on. So, now experimental study on photoelectric effect is done. Basically, the factors, what is the basic consequences on which the photoelectric depends. Does it depend upon the radiation of light? Does it depend upon the intensity of light? Does it depend on the frequency of visible light, etc. will be dealt in this complete concept now. So, experimental study of photoelectric effect. So, please let me just read on first of all. So, figure depicts a schematic view of the arrangement used for the experimental study of the photoelectric effect. So, this was the similar experiment, this was a similar arrangement which we also used in the previous discussion also. So, there is nothing new, there is a quartz window, everything will be dealt in as we go on, as we keep on discussing the complete points written here. So, as you can see, this complete experiment takes place in an evacuated glass tube. As you can see, there are two plates being kept here. One is the emitter plate, which is negatively charged, basically because of electrons, and then there is this plate. This is generally more relatively positively charged, so that the electrons are being attracted towards this. Then a potential difference is being kept between these two places here. This is a photosensitive plate, as in the plate which is sensitive to photons. Okay, this is a quartz window. The application of quartz window will be explained in the subsequent points here. And then there is a source which emits and let us say visible light, or let us say ultraviolet light, depending upon the plate which is being used. Fine. So, this was the complete explanation here. Let us move on and check what is being explained here. Okay. So, figure depicts a schematic view of the arrangement used for the experimental study of the photoelectric effect. It consists of an evacuated glass or quartz tube. As you can see, it is an evacuated glass or quartz tube having a photosensitive plate C, and another metal plate A, Okay. So, till now this has been explained, Monochromatic light from the source S of sufficiently short wavelength passes through the window W and falls on the photosensitive plate C. Fine, simply. So, monochromatic light. So, as in the light, what is a monochromatic light? A light which has a single wavelength is called as a monochromatic light. Okay. Let us move on then. So, monochromatic light from the source S, of sufficiently short wavelength passes through the window W. So, this has a very short wavelength, as in the value of the wavelength is very short, very small, passes through the window W. So, this is that window W being talked about here. Let us say I denoted by window W here, and falls on the photosensitive plate C. So, this is called as photosensitive plate C, also called as the emitter plate. Okay. Why it is called as emitter plate? As the name suggests, emitter, as in it is emitting something. In further discussion, we will get to know it is emitting electrons, hence it is called as a emitter plate. Okay. So, this thing has also been explained. Next is a transparent quartz window is sealed onto the glass tube. So, a transparent quartz window. So, this is being explained, a quartz window. Quartz is basically a material. A transparent quartz window is sealed onto the glass tube. This is basically the complete glass tube, which permits ultraviolet radiation to pass through it and irradiate the photosensitive plate C. So, what is the use of this quartz window? Basically, to irradiate only ultraviolet light through this window. This is its use. Okay. Finally, what happens is the amount of light, or the light which is irradiated on this photosensitive plate has a wavelength of such that it is ultraviolet light. Okay, and ultraviolet radiation is being impacted upon the metal surface. Which metal surface? The emitter plate here. Okay. The electrons are emitted. So, now as the electrons are emitted, hence this plate is called as an emitter. The electrons are emitted by the plate C and are collected by the plate A. So, this, as the name says, collector. So, it is collecting something. What it is collecting? It is collecting electrons. Hence, this plate is called as collector plate, and hence this plate is called as emitter plate. So, let me just write. because these things sometimes are a bit confusing as the complete syllabus goes on. So, this is called as collector plate. Sometimes people make mistake in, because as C is written here, so sometimes C they take it as it is C here, this may be collector plate. Please do not make this mistake. Emitter plate, why it is called as emitter plate? Go with the definition. Sometimes the definitions of some words are written in its in the spelling itself. So, as you can see, emitter plate. So, emitter, what does the name say? It is emitting something. That is why the C plate is called as emitter plate. In our sequence, in our complete detailed study, electrons are being emitted. So, hence it is emitter plate, and A is collector plate. Collector plate, as in why the name is collector plate, because something is being collected by it. What is being collected? Electrons are being collected. Okay. That is why C is your, just let me rub everything here. So, C is your emitter plate and A is your collector plate. Fine, then let us move on. The electrons are emitted by the plate C, quite evident, and are collected by the plate A, collector, by the electric field created by the battery. Okay. So, this last line is very important, because this complete passage of electrons from, let us say, point A to point B is only and only happening because an electric field is being existing between these two plates. Okay. You may have in the chapters of electromagnetic induction and your electric field, etc., current, electricity also, you may have heard these complete concepts, that the movement of electrons only occur or majorly occurs when the electric field is present. If there is no electric field, the amount of electric current produced is 0. Okay. So, that complete concept is being used here. This is just the application part of it. So, because only and only when the electric field is present, then only the passage of electrons take place from, let us say, one plate to another plate, or let us say point A to point B. Okay. Next is, the battery maintains the potential difference between the plate C and A that can be varied. So, this thing is basically under a potential difference. Okay. The polarity of the plate C and A can be reversed by a commutator. So, this is the thing which is called as a commutator. This is the designation of how it is being used. So, what is the usage of commutator? It is basically to reverse the polarity. Okay. So, the polarity of the plate C and A can be reversed by a commutator. Thus, the plate A can be maintained at a desired positive or negative potential with respect to emitter C. Okay. So, this is the theoretical part. For majorly part, the values are being intact only, but sometimes reverse polarity can be also being made into application. So, that thing is a little tedious part, we will not go into that much detail, but you should just know that what is a commutator. Commutator is basically used for reversing the polarity. Okay. Hence, the polarity of the commutator plates C and A can be reversed by a commutator. Thus, the plate A can be maintained at a desired positive or negative potential with respect to emitter C. Okay. Let us move. So, the potential difference can be relatively varied or decreased also and increased also. Fine. Okay. So, let us move on to the further discussions now. Okay. Now, when the collector plate A is positive with respect to the emitter plate C, the electrons are attracted to it. Okay. So, it is saying that collector plate A is positive, quite evident. So, it is relatively, if it is relatively positive and electrons are being ejected from this portion, what will these electrons do? They will try to get attracted towards this positive plate A, right. So, that thing is only written here. So, when the collector plate A is positive with respect to emitter plate C, so relative proportion is only being talked about here. Okay. So, when the collector plate A is positive with respect to emitter plate C, the electrons are attracted to it. So, as you can see, the electrons are being attracted to it, quite evident. The emission of electrons causes flow of electric current in the circuit. Okay. The emission of electrons causes the flow of electric current in the circuit. So, this concept has been explained in the current electricity chapter only, that is, what constitutes an electric current? The movement or the passage of electron from point A to point B constitutes an electric current. So, as there is a movement from, let us say, this point to this point, that is why there is an electric current flowing in the circuit, and hence the electric circuit is being made or it is closed. Okay. So, the emission of electrons causes the flow of electric current in the circuit. The potential difference between the emitter and the collector plates is measured by a voltmeter. So, this is that voltmeter being explained here, whereas the resulting photocurrent flowing in the circuit is measured by a microammeter, that is mu m. So, this is used for calculating the value of current. This is used for calculating the value of current, and this is used for calculating the value of voltage. Okay. Fine. The potential difference between the emitter and the collector plates is measured by a voltmeter, whereas the resulting photocurrent flowing in the circuit is measured by a microammeter. Okay. So, this is again theoretical portion only. So, you just need to explain so that you can understand what is happening here. The photoelectric current can be increased or decreased by varying the potential of the collector plate A with respect to emitter plate C. Quite evident, because even if you try to change this potential, then the amount of electrons will change, the amount of rate of acceleration of electrons will change. Because let us suppose, if let us go with a very layman language, let us say the amount of positive charge is very high here, then the attractive forces between these electrons and this metal plate will be much higher. Similarly, if the positive charges are very less here, let us say very less here, then the amount of attractive force related to the previous one will be much more less. Hence, the current will be less, because the current depends upon the rate of flow of charges from point A to point B in some time t. If the time t is constant, then the amount of charges, if the potential difference is high, current will be high. If the potential difference is low, then the current will be low. So, that similar thing has been explained here. Okay. So, if we try to vary the potential difference on the right hand side, then the current will also be varied. Okay. So, the photoelectric current can be increased or decreased by varying the potential of collector plate A with respect to emitter plate C. Okay. The intensity please remember please look over carefully now. The intensity and frequency of the incident light can be varied, as can the potential difference V between the emitter C and the collector A. So, even the intensity or frequency can also be varied as we try to vary the potential difference. Why I am being intensity, I am focusing about intensity frequency, because these are two of the greater things which we need to understand in photoelectric effect. What is the effect of intensity and frequency on the incident light? Okay. So, we can use the experimental arrangement of the figure to study the variation of photocurrent width. So, now we try to understand this complete arrangement, this complete photoelectric effect study using these 4 instances, these 4 different arrangements. What we try to do? First, we try to change the intensity of radiation, keeping all other things constant. Next time, we try to change the frequency of incident radiation, rest of the things constant. Next, we try to change the potential difference between the plates A and C, rest of the things are constant. And we try to change the nature of the material of the plate C, rest of the things are constant. So, let us go over every of the points very carefully, and then we can understand this complete experimental study of photoelectric effect. Okay. So, till now what we understood is that what is happening here, there is an evacuated glass tube, there is a photosensitive plate, this is between basically the emitter plate C, this is emitter plate, this is your collector plate. What is a commutator? Commutator is being used to reverse the polarity if required. What is mu A? Mu A is basically microammeter, which is used to calculate the value of current being produced in the complete circuit. When the current will be produced? The current will be produced only and only when the ultraviolet light, or let us say visible light, is being irradiated on the sample, and the threshold frequency, the frequency of that complete metal surface is greater than the threshold frequency. Okay. What is a voltmeter? Voltmeter is basically to calculate the voltage. We try to change, or one more thing, that we try to maintain the potential difference by using a battery. Okay. So, these all things were being explained. Quartz window is being used so that the only ultraviolet radiation is being injected upon from the source of light, and this is the source of light. Okay. So, this is the complete experimental arrangement being explained. Let me stop it here only. In the next class, I will start with the first point, that is intensity of radiation. So, we will try to understand this experimental study in very detail, and then we can move on further. Okay. So, let me stop it here only. Thank you.